Hello everyone. Today we're going to be talking about types of chemical bonds. So you should have your guide to bonding types sheet out in front of you. The three types we're going to be talking about are covalent bonds, ionic bonds, and metallic bonds. So this is a sheet you should have out in front of you. We're going to go through and just fill the whole thing in together right now. I'll elaborate a little bit on a few things, but I'll tell you exactly what I would like you to have written down. And then afterwards, I'll give you a chance to get the homework, and then we're going to go through a couple on the homework together for today, where we're going to be basically identifying chemical bonds based on some of the properties that we're going to go through on this chart. So the first thing that we're going to talk about is just how each type of bond is formed, actually. So we're going to take a look here. I'm going to draw a couple things out, and then I'll actually fill in on the chart when we're done. So first of all, we've talked a little bit about covalent bonds before, but we should know that a covalent bond is from a sharing of electrons. So you can just write sharing of, and then either electrons or E minus or something of that sort. Okay, so that'll go actually in your little box. So remember the other day when we talked about, this is like when we have chlorine and another chlorine, and basically what is happening here is that these two electrons, which would be here and here, are bonded together, and these two chlorines will share those electrons. Now the next type of bond is called an ionic bond. So just so we're being clear right now, sharing of electrons goes right here where we say how it bonds. Okay, so for covalent you write sharing of electrons. You do not need to draw the picture. Next we're going to talk about ionic bonds. So when we have an ionic bond, basically what's happening is we have something like lithium, and it has one electron like this, and then we have something like fluorine that has 7 electrons, and lithium gives this electron away here. Okay, what happens then is we have a lithium with a positive charge and a fluorine with a minus charge, and essentially they just stick together. So in your box down here you can write, it really is an electrical, so I'm going to do my best to fill in right here, electrical attraction. Alright, now finally, the last type of bond that we're going to talk about is a metallic bond. And all a metallic bond really is, it's kind of hard to describe it for you guys, but the best way to describe it is by kind of actually looking at this picture over here. So if we're looking at the picture, we have a bunch of metallic ions together over here. So we're looking at this picture. The red are representing basically free electrons. So essentially what's happening is all these metals are sharing all of the free electrons, and that's how the bond is formed. So really a metallic bond is the best way to describe it for us is it's a bond that happens in metals. So essentially it's only going to happen in metals, like it happens in gold, it happens in copper, and it's where it's a pure metal essentially bonding to itself. Okay, so those are how they bond. So once again, right here you should have sharing of electrons, and over here by metallic bonds you should have bond that happens in metals. So that's why I'm kind of blowing that up so it's easier for us to see that. Now we're going to talk about the types of atoms that are involved in each of these chemical bonds. So in a covalent bond is going to be between non-metals and non-metals. Next, we're going to talk about an ionic bond. And an ionic bond is going to be formed by a metal, so something like sodium, lithium, gold, iron, any of these things, and it's going to be bonded to a non-metal. So things like oxygen, fluorine, nitrogen, phosphorus, these kinds of things. Okay. Lastly, for types of atoms, this only happens in metals. And they have to be the same atom. So we can finish with atom over here, and you just got to fit that in. Okay, so the only metals are the same atom. So like I mean is it's all copper atoms, or all gold atoms, or all silver, or all some sort of atom. Okay, now next for conductivities, you're going to write for covalent bonds. So this is how well things conduct electricity or heat. For covalent bonds, you're going to write that they have a low conductivity. Okay, so we're speaking relatively here, so compared to the other two types, obviously. Next, we're going to look at ionic compounds conductivity. So if we zoom in on this picture here, and this is the box for conductivity for ionic compounds, so you can kind of see that right now. If we take a look here, the light bulb is showing that it's conducting electricity through this current. And what we've done here in the picture is this is blown up what the water looks like. So ionic compounds are going to conduct electricity, so they're going to be high levels of conductivity, but only when dissolved in water. So when an ionic compound is dissolved in water, it's going to conduct electricity really well. For example, if you dissolve salt in water, that thing is going to conduct electricity well. Next, when we do metallic bonds, so what's happening here is we're showing a picture of copper here. Okay, so we're talking about copper's conductivity. Now we should all be aware that we use copper wire to conduct electricity. And why? Because copper conducts electricity extremely well. If we used gold, gold actually conducts electricity even better than copper, but it's very expensive. So here we have a picture of copper wire blown up, and this is the copper wire, and then down here is what the copper wire would look like at the atomic level. Now all these little things with arrows are representing electrons, so you can see that because there's electrons in the copper, it can conduct electricity very well. So here we're going to write high, and that's when solid. So anytime you see something solid that conducts electricity well, you can assume that it's probably a metallic bond. Okay, next, melting points. For the melting points, we got to look at a little bit at the structure of what compounds look like. So if we blow this up here, we're looking at an ionic bonded compound versus a covalent bonded compound. Now you can see that the ionically bonded compound, this is like sodium and chlorine, they fit together really nicely, right? Like they're tightly packed together. You can see here's a positive ion, here's a chlorine, and they're all tightly packed together. Now if we look over here at our covalent compounds, when we're talking about a bunch of them connected together, they're not very tightly packed together. What this means is that covalent compounds have very low melting points, and ionic compounds are going to have very high melting points. And we're not going to get into it too much with metallic bonds, but what do we know about metals? We should probably know already that things like copper, gold, all kinds of metals, iron, they're going to have very high melting points as well. So we write high over there too. Okay. Next, electronegativities. So when we talked about the electronegativity, we're talking about the bond and whether a bond is polar or nonpolar. Now we should be familiar with this already, since this is what we did in our Lewis Structures lab. So we should have a lot of practice with this. And we know that the electronegativities for a polar and nonpolar covalent bond. We know that for nonpolar, the electronegativity is between 0 and 0.4, and we should know that for polar, the electronegativity is from 0.5 to 1.7. Now, some of us are asking the other day, well, what happens if it's greater than 1.7? Well, if the electronegativity is greater than 1.7, this would be when we have an ionic bond. So over here, you can write greater than, so like this, 1.7. So for an example, if you look at your electronegativities chart, you would see that fluorine has an electronegativity of 4, while lithium is 0.9. So if we take 4 minus 0.9, we're going to get 3.1. So we would say that this would be ionically bonded because the electronegativity difference is greater than 1.7. Now, for metallic bonding, just write a line through it. We're not going to worry about electronegativity difference for metallic bonds because it's a bond between the same metal. Okay. Last thing we're going to talk about here is the solubility. So underneath solubility here, I'm going to move this out of the way quick. But we're going to have a definition for solubility. We don't really know what that is, but we're going to do a lab on it next week. But solubility is basically the ability to be dissolved. So if something can be dissolved in water, we say that that thing is soluble in water. Okay, and solubility is going to be different for a number of different things. Okay, so for instance, something like a polar covalent bond is going to be, and you're going to write this down, and we'll talk more about this when I get back on Monday, but it's going to be dissolved by polar solvents. Then, for a nonpolar covalent bond, you're going to write it is dissolved by nonpolar solvents. So, just to give you guys an example of something that you actually know a little bit about, everybody has probably cooked bacon and tried to wash the pan free of the bacon grease before. And you'll notice that if you do this with just water, the bacon grease doesn't come off the pan. That's because bacon grease is nonpolar and water is polar. But as soon as we add soap, the bacon grease is able to be washed away. That's because the soap is a nonpolar molecule. And like I said, if this doesn't make as much sense right now, we're going to go over this again on Monday. Okay. For ionic compounds, you're going to write dissolved in polar solvents again. And then finally, for metallic bonding, just write that they are not soluble. And what that basically means is that they cannot be dissolved. Okay, so if you take a look here, just to wrap up everything that we should have in our boxes, your boxes should look like this, so that's all your notes. And then next we're going to go on to your worksheet. So right now we can pause the video and get the worksheet passed out to everybody. Alright, so the worksheet is pretty self-explanatory, but I just want to go over a few things. So for the first part, for number 1, so right here, we're talking about defining covalent bonds and give an example. All I really want you to do there is say what makes a covalent bond, what makes an ionic bond, and what makes a metallic bond, and give an example of each. Okay, so what are some elements that make up a covalent compound? What are some elements that make up an ionic compound? And what is a metallic. What is an example of a metallically bonded compound? Next, you're going to use your electronegativity chart. So that's the chart that we've been using. It's the half sheet to determine the type of bond between these. So we've done nonpolar and polar before. Now we're just adding ionic. So that's for these right here. After that, you're going to use the chemical formula to determine the type of bond that forms. So this is where we'd use our notes on type of atoms to kind of help us decide, what type of bond is forming. So it's going to be metallic, ionic, or covalent. And then for number 6, this is a list of basically solvents. Now when I say it's a solvent, it's something that something else can be dissolved in. So I'm trying to help you out here in writing if it's polar or nonpolar. So like here, water is something that we can dissolve things in, so I wrote polar. Ethanol is something we can dissolve things in. It's a liquid and it's nonpolar. C, soapy water would be nonpolar, or D, it does not dissolve. So for example, if we're going through this, we'd use our notes on the solubility, and you look and see, okay, so the first one's bacon grease, and it says that it's nonpolar. Well, what do you use to dissolve bacon grease? Well, you use probably C, soapy water. Now, for some of these, such as this one, CCl4 and NaCl and BAI, what you're going to need to do is figure out what type of compound it is, and then use your solubility notes to help figure out what it would be. So if we just did NaCl, we'd first have to look and see that, okay, sodium is a metal and chlorine's a nonmetal, so this must be an ionic bond. And then we look, okay, we see what does ionic bonds dissolve in? Well, they dissolve in polar molecules. So here we would put A, they're going to dissolve in water. On the back side, you're going to use the conductivities to determine if something contains a metallic bond, covalent, or an ionic bond. And so the conductivity here is just giving you in parts per million, but all you're doing is using it comparatively. So if something's a really low conductivity, it's probably a covalent bond. If it's a high conductivity, it's probably an ionic bond. And if it's a solid at high conductivity, then it's probably a metallic bond. All right, that should wrap up everything. So if you guys have questions, I will be back on Monday, and I hope you all have a great weekend.